Today on Epic Projects, we discuss working with municipal clients, specifically in the state of Arkansas. We're talking to Chris Ladner, founding partner of Entegrity Energy, about working with schools, wastewater treatment facilities, and just generally working within the budgets and site constraints of these particular clients. Hey, Chris, thanks for taking the time to chat today.
Glad to be here.
Ever since Arkansas passed the Solar Access Act in 2019, Entegrity Energy has been installing all kinds of solar arrays for municipalities in the state, from schools to wastewater treatment plants. And I'm just curious, at any one time, how many projects might you be working on?
We're a little non-traditional when you look at a lot of just straight up solar developer types. We provide a multitude of services to our clients. We started out as a consulting company for really green buildings, energy efficient buildings. And then kind of second phase of our company, we started to provide turnkey energy services. And that was really both defining what needed to be done, but also installing it. So that includes HVAC, lighting, water conservation, wastewater. From a consulting standpoint, work on, I'm sure, well over 40 consulting projects. I think our turnkey energy projects, which are much larger projects, are probably 25 of those. And then it depends on when you ask. What I say currently, we have 21 to 24 active solar projects, somewhere in that range.
So I want to zoom in on a few of those projects, but still kind of starting generally here. What differentiates a municipal solar project versus maybe a similarly sized commercial job?
The real major difference between those projects and then the private projects we do is really the finance rate and the term. I mean, there are other nuances here, procurement strategies and things of that nature. But really, when you look at the success of the project, it really comes down to the fact that a tax-exempt client has the advantage of the low-cost long-term debt, but they can't take advantage of, directly anyway, they can't take advantage of federal investment tax credit, which obviously can have a significant impact. So, that's kind of their side of things. And then the other side of things, the time horizon and resulting levelized cost of energy for C&I clients can be higher because they might not look as long-term, whereas a tax-exempt client might be looking at a 20-year time horizon or things like that. A C&I client might be looking at a 10-year, and their cost of capital can be different as well. You're also competing with their core business and making sure that the return on the capital that they're using for your solar array has at least a close return on capital and provides other benefits, carbon, the marketing side of it, what have you. So for a lot of schools, it brings money to the table in a way and allows them to leverage the whole project to maybe upgrade those HVAC systems that otherwise they wouldn't be able to upgrade. So solar is it's amazing how it's flipped for us.
You did mention the nuance. There could be nuances in the procurement. Is there anything to note there?
In Arkansas, there is most public entities have the ability to procure energy savings measures through a energy savings performance contract or some kind of paid from savings strategy that allows them to fund their debt with savings. Solar can live within that procurement method. Clients might want to bid projects. We don't see that as much because of the development of the project itself can be costly. The markets that we really care about, these more rural school districts, rural communities, you've seen some of the sizes of the projects we do. So we want to make sure we serve those communities. Well, those communities also don't have as robust support structure to do, project development, RFP development, things like that. So they're looking for a partner.
Let's look at a few of these projects. You worked, one that stands out to me is you worked with two school districts, Cedar Ridge Schools and Midland School District, on a 1.36 megawatt single axis tracking system that operates on one of the school's grounds.
Mhm.
I guess I was first curious, when you're co-locating a project like that, does it make things more complicated?
It kind of has to. We're dealing with two entities. Typically, in those situations, you have one client that's somewhat site constrained. Our development folks did a really good job of coordinating with the two school districts. I think everyone recognized the opportunity to be able to kind of co-locate and put together one array, in quotes, but be able to share in those economies of scale, share in the land opportunity. And it's really kind of a great message, at the end of the day. But yeah, there are challenges, there's coordination challenges, but I don't think we have one preferred strategy. If someone wants to co-locate, we're super excited about that. And I think we've, learned a little bit more about how to really make sure that's done as smoothly as possible.
That array was built on an existing hayfield next to the school that is used by the Future Farmers of America program.
Yeah.
So I was curious, did you design that one with agrivoltaics in mind?
It wasn't designed in necessarily up front. It's been a great test case for us. You just say, sheep grazing and taking care of your vegetation management. That just sounds awesome. And it can be, but there's also those unintended consequences of some decisions sometimes. There's the details that need to be worked out. And having a partner with the school, they've learned a lot about the agrivoltaic opportunity, all these issues related to ground conditions, the ability to have the kind of vegetation that the sheep want to eat, how many sheep you need per location, per acre, rotation of them between the two arrays. So we made a few adaptations, I think, to accommodate that, but it wasn't necessarily designed in. And I don't think it's the structural side of things has been a challenge. It's more just the operation side of managing the sheep and the varying conditions, when, like, especially right now with drought conditions, how do you handle that if we're not getting a lot of growth and there's not as much resource for the sheep? How do you handle that?
With another school project, I kind of wanted to compare and contrast two projects that are kind of similar sizes but different use cases. There's a project you installed that was like a 341 kW array for another school district, Concord Public Schools. And then in Prairie Grove, you built a 498 kW array at a wastewater treatment plant that city officials say will stabilize water rates. Beyond matching the unique power needs of the facility, can you compare and contrast decisions made there?
I know for sure the water rate stabilization was a big driver, and it should be. It allows them to really lock in their utility cost, a large percentage of the utility cost, and be able to budget that going forward. So it takes another variable out of the equation for them when you look at water rates. Both these projects had land challenges, and that's the other thing when you deal with smaller clients. I think both those arrays ended up being fixed. It turned out that fixed arrays just work better there from a cost benefit standpoint. When you're doing smaller clients and you don't have a vast amount of space, you have to have that level of flexibility, from ballasted systems to fixed systems to single axis tracking, roof mounted.
What are the ground conditions generally in Arkansas?
I went to college in the Midwest, and I'm a little jealous of the opportunities they have. We have really varied conditions depending on where you are in the state. The kind of, the delta, sandy, loamy ground, which if you kind of bisected our state from the northeast to the southwest, the bottom half of that triangle is more of that kind of delta loamy, which is great, except that they're prone to a bit more water retention. We have embed depths that need to be deeper to make sure that we meet the load requirements. But the minute you go to the top half of that triangle, things change significantly. You get into the Ozarks, we have a lot of rock that we have to deal with, and we experience refusals, when we're trying to do installations in those situations. And, it's not consistent. I mean, we might be fine embedding our piles for quite a ways, and then all of a sudden you run into rock and you have to go back and do a core and pour, a drill out and grout or concrete those piers to make sure that you meet the load requirements in those situations. So we kind of have to be prepared for all of it.
Solar just seems like a pretty good deal for public facilities in Arkansas right now.
Yeah.
To me, it just feels like they should be, beating down your door. That's never usually the case. Just curious, what hesitations or challenges still exist when approaching these projects and getting them across the finish line?
It was a slow start after the Solar Access Act was passed, and that it's understandable. Utilities are getting their legs under them on how to interface with this new project that they probably hadn't staffed up for. But as we've gotten into it, I think everyone's gotten better at this. And we're doing a project, the University of Arkansas Hope-Texarkana project. It's a municipal utility. They have different rules, different opportunities, and they also have other resource constraints of their own. That project started as a solar project, and at this point, it is a solar project for the school district and the college. And then the college had a power technologies program, and we have now added NABCEP certification. So we have a lab that has been installed at the college. We built a workforce development center for them that houses some different programs. So it was and we did energy efficiency. So it was a really great, a project from a comprehensive standpoint. But what we really love about it is that, us and our partners got engaged on helping with the solar lab so that we could really start developing, the next crop of solar installers.
Wow, that sounds like a really cool project. Who are some of the partners working with you on that one?
So, AMCO is a partner of ours on the majority of our projects. They've been involved with us since day one. And, it's great to have a partner that can balance, the competitive, first cost profile, great support with operating costs, and also just a good partner when it comes to trading information. They provided the racking on that lab, which was, really generous of them. And then for solar, who is another partner of ours, another, great vendor that, really aligns with our mission and kind of how we approach the market. They've gotten engaged and supported that project as well. And as well as some of our, subcontractors that have worked with us on installation and so on. So it was really just, just a great project to have that kind of team step up and do it. And, we've all benefited from the market here. And I think giving back a little bit everybody was really happy to do that, especially when it comes to something like a solar lab. The students are going to walk out with NABCEP certification.
Thanks for walking me through all this. A lot of great insight on what's going on in Arkansas, and I'm glad to
Sure.
hear that the momentum's going to keep on going.
Of course, Chris, really enjoyed it.